Hi everyone, welcome to the Success Classroom online video. This is a preview video on measurement where I will problem solve 5 measurement questions. Okay, question 1 shows 2 diagrams. So diagram 1 shows the calipers when the jaws are closed, where diagram 2 shows the calipers when the wire is between the jaws. So let's take a look at diagram 1. Okay, for diagram 1, you notice that the zero marking on the main scale and the vernier scales are not aligned. So, and in this case, the vernier scale zero marking is to the left of the zero marking on the main scale. So what we have is that we will have a negative error. So this is a negative error. Now how do we read negative error? We will read the error starting from the right side of the vernier scale. So in this case, you look at the you notice that it's a third division that actually is aligned with the main scale. So in this case, we will have a negative error of 0.03 cm. Okay, and then we look at the uncorrected reading here, where we try to measure the length L. So you notice that on the main scale, the fourth division is aligned with the zero marking. Okay, the fourth division, the fourth marking, which is here. So we have the main scale reading 0.4 cm. Okay, notice what happened is that the zero marking is direct. The zero marking on the vernier scale is directly aligned with the top. So in this case, there is actually no reading on the vernier scale. So which means that 0.40 is the uncorrected reading. So to get the corrected reading, we will always take the uncorrected reading minus the zero error. So we will take 0.4 cm. We will minus. You let the math do the job for you, so you have a negative 0.03. Right? So if you actually work out the answer here, is 0.4 plus 0.03, and that will give us 0.43 as the answer. For the second questions on micrometers, so again, when this part shows a zero error, so you notice that the datum line, this is called the datum line, okay, this part here is called the datum line, this line, right? This datum line is not aligned with the zero marking on the timber, okay, it's not aligned with the zero marking on the timber. So what we do is that we will now have to know that there's a zero error. So in this case, there is actually a negative error as well. So there's a 3 division difference. Okay, so this will be a negative 0.03 mm. Okay, so the unit is all measured in mm. Then we look at the diameter reading 1, 2, 3, 4, 4.5. So this is 4.5. Right, 4.5, and then we're going to add. So you have 30, 31, 32. So you see that the 32, the 32nd division is aligned with the datum line. So it's 0.32. Okay, you add up these two, you end up with 4.82 mm. So same thing, we will always subtract zero error. So we will take 4.82. We will minus negative 0.03. Okay, you will have this. So this will end up with 4.85. So answer C. Okay, for question 3, we have a micrometer, which is used to measure the thickness of a piece of gold bar. So figure 1.1 shows when the jaws are closed, and figure 1.2 shows when they are measuring the gold bar. So what happened is that you look at this, and the figure 1, you'll notice that the zero marking on the timber is obviously not aligned with the datum line. Okay, and in fact, the 16th division, okay, which is somewhere around here, the 16th division is aligned with the datum line. All right, and obviously the zero marking is somewhere below this, below the timber, below the datum line here. So what we have is, in this case, there will be a positive error. Okay, because the zero marking is below, right? It's below the datum line. So the zero marking on the timber is below the datum line. So we have a positive error. So this is a positive error, and it's the 16th division, so 0.16. Okay, and this is in mm, right? And then we look at the figure 1.2. So for figure 1.2, what we see is that we have the marking at the bottom that appear out of the timber. So this is 2.5, right? 2.5 mm. Okay, 2.5 mm, right? Every division on top is 1 mm. Every division below is 0.5. And then we look at next is a timber reading. So this value that we have is 26. So it's a 2 decimal place in mm, so 0.26 mm. You add up these two, you end up with 2.76. Alright, 2.76. So 2.76 mm is the uncorrected reading. So same here, we're going to subtract 0 error. So you take 2.76, you will minus away positive 0.16. Okay, so we're going to subtract this. So what we get is you have 2.76 minus 0.16, and the answer will end up with 2.60 as the answer. Okay, for question 4, we have a pendulum which starts to oscillate from point X, it goes to Z, and then after it goes to Y. Notice that this is not one complete oscillation, right? It's only 3/4 of oscillations. So 3/4 of an oscillation, which is 1 period, time taken for 1 period, will be equivalent to 0.6 seconds. So the time taken for one oscillation here, so we're going to take 0.6 multiply by 4 divide by 3, and that will give us 0.8 seconds. So this is the time for one oscillation. To make 20 oscillations, very simple, we will take 20 multiply by 0.8, right? And that will give us a time of 16 seconds. So answer is C. Now for question 5, this is again a measurement questions. So a plumber try to measure as accurate as possible the length and internal diameters, right, of a straight copper wire. The length is approximately 80 cm and the internal diameter is approximately 2 cm. And which is the best combination of instrument for the plumber to use, right? As a rule of thumb, general rule of thumb, I would say a vernier calipers, you usually use it to measure length from 1 cm to about 10 cm. Okay, 2 dp accuracy, of course, in cm. For meter rule, we will generally measure anything that is more than 10 cm, alright, okay, to less than a meter, alright, to 1 meter, right, to 1 meter, right. So if you look at this 4 options here, I will say that the length, you can actually use the meter rule to measure, whereas for the internal diameters, you will use the vernier calipers, right? So choosing the option, answer will be C. Okay. This is the end of our preview video 1 for measurement, right? Thank you for watching. For more details about my academic videos, please visit the successclassroom.com.